Hello, welcome to the podcast of Wageningen Alternative Protein Project, where people talk about their work in protein transition. I am Shan, a master's student in food technology, and I will be your host today. Our guest today is Rebecca Ronchi, who is a PhD student in fermentation. Hello, Rebecca. It's great to have you here for our podcast. First of all, would you like to briefly introduce yourself?
Hi. Yeah, it's very nice that you invited me to talk for your podcast. My name is Rebecca. I'm an Italian PhD student working in Wageningen University. I'm 27 years old and I did my master here in Wageningen in food technology. I like to cook and I really like cats.
Oh, do you have a cat?
No, I'm allergic to cats. That's the other sad part, but I have a lot of cat pictures in my room.
That's also good enough, I guess.
Yes.
What background did you have before starting your PhD project?
So I did my bachelor in Italy, in the University of Perugia, and I was doing a bachelor in food technology and agriculture technology. It was quite interesting. The exams that I liked the most and the projects that I liked the most were all microbiology related. So then I came here to Wageningen University, and I also decided to go on studying food technology, but I did my specialization in biotechnology and biorefining, which is the first specialization in food technology where you basically study on how to use microbes to produce tasty food. And after that, I did my master thesis in the food microbiology department, where I work now, supervised by Adi Smith. Did my master thesis on seaweed fermentation, and then did an internship at Kraft Heinz. And afterwards, I worked for a month at Kraft Heinz as a product developer, and then resigned to start this PhD.
So you didn't just start a PhD directly after study, but instead you worked for a little bit to figure it out.
Well, I mean, I just worked for a month, so before starting my PhD. So yeah, it's quite negligible, the experience that I have in a company, I would say.
Okay.
Almost started straight away.
Okay. Then what is your motivation for this project that you are working on in particular? And would you like to share with us the title of your PhD study and maybe a little bit introduction of what your project is about?
Yes. So the main motivation is that I found this project very interesting and challenging. First of all, I really like microbiology. So for me, having a PhD in microbiology, it's really great, especially food related. And then I thought it's a topic that at the moment is very relevant and it's very important because it's about protein transition. It's about creating better meat replacers. I have to say I'm not a vegetarian. I'm not vegan. I really love meat. I eat meat on a regular basis.
Yeah.
But I do acknowledge the fact that we need to shift and have lower meat consumption that we have now, have less meat, better quality meat, and try to introduce alternative proteins in our diet. So I thought it was really challenging, and it was very, very interesting to have this opportunity, especially because, well, as I said, I do like meat, and so I wish to help creating better meat replacer that would also help me to reduce the amount of meat that I eat and have more meat replacers that have a nice flavor, for instance.
I can totally relate to you about that.
Yeah. The title of my PhD study, well, we are part of this project that is called B12 Insight, and it's a project in which 4 different companies are taking part. One company is Downy, the other company is The Hobbit, then there is the Vegetarian Butcher, so the Vegetarische Slager, and then Givaudan. Together they are funding the Food Microbiology Department and WFBR, which is Food and Bio-Based Research, the department of the university. And it's a big project that takes the research on meat replacers and alternative proteins from different standpoints, from different point of view. Indeed, this project revolves these different partners. Each one of them is interested in a different part of the project, but the project is divided in 5 work packages. The first work package is about thymine production and the thymine as a meat aroma precursor. So basically what we're doing is trying to produce as much thymine as possible to create a natural meat flavor. Thiamine is a meat aroma precursor, but probably we'll talk about it later. Then the other work packages of the projects are about vitamin B12 fortification in tempeh and in other pulses or other plant-based material. And then also there is a work package that is looking into other fermented flavors obtained using different microorganisms and different substrate. And a part of the work package is also about vitamin B12 and vitamin B1 analysis, because of course all of us are working on this vitamin B1 and vitamin B12 production. So we also need to have good analyticals to be able to detect in a reliable way and in an easy way these vitamins in the substrate that we're working on.
That's really a big project. And
yeah, it's quite big.
Yeah, and also like it sounds pretty broad, like insights into vitamin B12, right?
Yes, yeah, it's quite broad, and there are different partners, different people, different research, and I'm just a tiny drop of the whole project because I'm just responsible for one of the work packages out of the 5 of them.
Yeah.
So it's really something broader than just looking into vitamin B1 production.
Yeah, I see. And I think I've heard of the tempeh and vitamin B12 research before in the class. So I didn't know there's an ongoing project still right now. I thought it was done years ago.
Yeah, it's still an ongoing project. It started many years ago, but as you know, research takes quite long. So some years ago, they just started looking at tempeh and lupin tempeh and vitamin B12 fortification, just to meet the same nutritional requirements that, for instance, a steak can give you, the same amount of vitamin B12 that some meat based product can give you. And the project is still ongoing. You know, we're looking at different aspects of the fermentation. We're trying to make the fermentation more reliable, to have higher amount of vitamin that is produced. And we're also looking on how to optimize the factory production, and also how to have the best condition to produce the highest amount of vitamin B12.
That's actually a very important subject for people who are either going for a vegetarian or a vegan diet, or just people who want to reduce their animal protein consumption. Because
definitely,
that's a vitamin that's not usually found in plant tissues. That's very interesting.
Indeed.
Can you explain a little bit why is diamine chosen as a precursor in this project?
Yes. So diamine, it's already well known to be a very important compound that contributes to the formation of meat flavor when meat is cooked. In a more broad way, there are different reactions that contribute to this aroma formation. We have the Maillard reaction. That is a reaction that occurs between reducing sugars and amino acids, and you form all sorts of heterocyclic compounds and sulfur-containing compounds as well that give a nice, savory, meaty, roasted flavor.
Yeah.
Then another important reaction is the lipid oxidation. And all the lipid oxidation and degradation that occurs when you cook give a fatty aroma to cooked meat. Then the compounds that come from the Maillard reaction and the lipid oxidation can further react with each other to form other compounds. And then thiamine is also very important because alone thiamine degradation can bring to the production of different sulfur-containing compound that also contribute to the meat flavor. Thiamine is composed of 2 subunits, a pyrimidine subunit and a thiazole subunit, and the thiazole subunit of the molecule contains a sulfur atom that can react in different ways, and it forms all sorts of thiols and disulfides and other molecules that are really, 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 I would say, flavorful and tasty. So that's why thiamine was also chosen. And at the moment, we know that many meat flavors that are sold are also thiamine based. So it was the right molecule to target for production, especially because it can be produced by microbial fermentation.
So basically, thiamine is the single substance that can degrade into a lot of different flavors, and they contribute greatly into the meat flavor.
Yes, correct.
Then, apart from the flavor indication, any other benefits will thiamine provide for plant-based meat alternative?
I think it's mainly really about flavor at the moment, what we're looking at. What the thiamine that we want to have in a substrate that we ferment will be degraded mainly to form the flavor aroma. So in that sense, I think that thiamine won't have any other use. That is to say that fermentation in general has some benefits. So there are some health benefits that are being studied and related to fermented product. And also we know that vitamin B1 deficiency, so thiamine deficiency, is quite a serious problem. At the moment, not many people are thiamine deficient. So if we think of health-wise, it's really rare to have a thiamine deficiency, especially because thiamine is found in many grains and many other products. It's also found in meat. There have been some studying, and they see that alcoholics can be deficient in vitamin B1. There were also some studies in which they tried to produce beers with high levels of thiamine for enriching them for like health purposes. But I'm not sure whether fighting thiamine deficiency in alcoholics can be really solved by adding more thiamine to beer. I'm more like a fan of solving the problem itself rather than the symptom.
Yeah, I agree. That's a very interesting way to approach that problem. Actually, I didn't think that. Yeah, that could be one of the solution, but
yeah, it's arguable, I would say. But yeah, so at the moment, what we're mainly looking for is flavor. We're not really looking at other things, but all the benefits that come with the vitamin B1 fortification are for sure welcome.
So it's still more about flavor in this research.
Yes.
Do you think that natural aromas are key to the advances in acceptance in plant-based meat replacers?
Well, I think that for sure it can be. At the moment, natural aromas and the natural food trend is really horizontal across the whole food production category. And I think that all the consumers are very interested in the so-called natural products. So for sure, also certain consumers might prefer naturally enriched food product through fermentation compared to some artificial flavorings, for instance. So I think it's very challenging to create all sorts of naturally fermented products. At the moment, this natural trend gives scientists a lot of challenges and a lot of opportunities. The opportunities because we need to find a way to enrich substrate and create certain products without doing direct genetic modification, for instance, CRISPR-Cas, that at the moment is also not allowed in Europe. But this also poses a challenge because, of course, reaching certain targets, doing it just by studying a microorganism and by looking at all the natural way you can achieve them rather than doing a genetic manipulation, that it's much more straightforward and easy. It's really challenging. So I think that natural aromas are for sure a key to advance in the acceptance towards plant-based meat replacers, and it's a fun challenge for this, very fun challenge for the scientists that are working on that.
Do you personally get plant-based meat products and cook it yourself?
Yes, sometimes I do. I really like to try them because I think that at the moment it's really an expanding category. And every time I go to the supermarket, there are new food products, new brand, new different plant proteins. There are those that try to imitate meat, but there are also those that are just like completely different. You think of tempeh, it's not really like meat-like product, but it's also a very interesting protein. So sometimes I like to test them and I like to try them. For instance, as soon as the, how was it called? The Impossible Burger, or was the Beyond Meat Burger? One of the two of them.
Yeah.
I think the Beyond Burger, was sold in the Netherlands. I went to the supermarket and I bought it immediately and I tried to taste it myself. So I'm definitely interested in it.
Well, what do you think of the flavor?
I think it's fine.
Yeah, because your research is on producing natural aromas for that could be used in application of meat replacer production. So I'm just curious about your view of the current alternative meat product in the market.
Meat flavors?
Yeah.
I think most of them, they have a good flavor. Not all of them are really completely identical to meat. I do find difficult to find certain products that have the same aroma that you have when you cook meat. But definitely we're really on a good track at the moment. And sometimes maybe the flavor of certain meat replacers is not identical to the flavor of meat, but for sure it's pleasant, for sure it's meaty, for sure it's nice. So I'm quite positive. I think the biggest challenge is not just to look at the flavor, but to look at the product in the whole also from the nutritional value, from the nutritional perspective, but also look, for instance, at a different type of texture, different type of composition, especially if certain meat products wants to be as meaty as possible. At the moment, everything that we find in the market, it's more or less imitating either chicken breast or mincemeat. I'm really a fan of complex meat pieces, for instance, a whole chicken leg with the bone and the skin. So I find it a bit difficult to find a good substitute, for instance, to a chicken leg that is not just about the texture of the meat itself that can be easily reproduced, but it's also about all the other components of the meat itself.
Yeah, definitely.
That's, at the moment, I couldn't find anything similar.
Do you think there are other possibilities of producing other aromas through fermentation?
The meat aroma, you mean, right? Yes, the possibility of producing new aromas with microbes and substrates is infinite. If you think of all the microorganisms, the food grade microorganism we can use, and all the food substrate, different substrate that we have, the possibilities for aroma, it's really, really endless. So for sure, there are going to be some meat-related aromas that can be produced. I have a little example. When I was doing my thesis on seaweed fermentation with Eddie during my master, I decided to ferment some seaweed with different seaweed isolated microorganisms. And then I just did some flavor analysis and I put my samples in a GCMS to measure which kind of volatiles were present. And it was not very flavorful, like there were not very big standing out peaks. There were a lot of different small peaks, and different compounds that were formed through fermentation that were not present in my control samples. And we found in very, very low amount a compound that was also found in some fermented salami from Sicily, or like from some certain salami that we found, Italian salami. Well, that was quite interesting. I mean, of course, it was produced in small quantities, and I was just basically trying to Google the compound to see what it was found and was of interest. So yeah, that's an example. There is another example. Some time ago, Eddie went to a food fair and he was approached by a lady that had fermented some mushroom at home and handed him a sample of this fermented mushroom. And this fermented mushroom had a very fishy smell. That really smelled a lot like, I would say like shrimps. So as you can see, it's quite interesting. You start with a product and a microorganism and you don't know where you end up.
Yeah.
Afterwards, we just put this sample in the GCMS to look at the different flavor compound, and we couldn't find any shrimp-related peak, mainly because we found a lot of mint compounds, like a lot of essential oil coming from mint and thyme compounds. We were really puzzled by it. And then after a while that I couldn't understand how these compounds that are not found in shrimps are not found in mushrooms that are not microbially produced. Well, I found out that the container that the woman gave the sample from was a mint container, was a container for like little candy mint. So the sample that she gave to us was totally contaminated, and that's why we couldn't really analyze the different we really couldn't analyze and find the different flavors. But the only big peaks that we were finding coming from the GCMS were those that were mint related, because she just used the wrong container.
Well, that's really funny, but it must be really frustrating to be the person who tried to solve these kind of puzzles, because you literally can't control like how would you know like the container contained before it was that. But
I totally didn't expect it. So at the beginning I was looking and I was like, where do this compound come from? There are no microorganisms that are known to produce them, but they're also not really found in the mushroom that she used. So where can it come from? And then I just assumed it was a contamination, and I checked the container, and the lid of the container actually did smell like it smelled like that, but then the fermented mushroom didn't have the smell, but it was all contaminated, so
you couldn't use it.
Couldn't work with it. No.
Okay. Then you are not able to figure out, like even if it smells like meat, fish, it doesn't contain any fish-related flavor compounds. Like you weren't able to look deeper into it.
No, we were not able to look deeper into it, but that's just an example to tell you the possibilities are really, really multiple.
Yeah, and I guess the human olfactory sense is probably very complex. It's not about, you know, a single compound. It's more about a total, like like a combination of different kinds of compounds that lead to people thinking that this is related to this food or the other. So
yeah, that's true. I'm not really an expert into that because I'm more a microbiologist and I work mainly with microorganisms.
yeah.
But I know also something about this analytical procedures to measure volatiles. And what we see is that there is a not enormous, but there's quite a big difference from what actually our olfactory system perceive and what a machine can perceive. Our olfactory system can be much more sensitive to certain compound compared to a machine. And I probably also the other way around. I'm not really sure about it, but I know for sure that sometimes the human nose perceives things in a different way than what's the output of a machine. Yeah.
That's very, very interesting.
I mean, this is what I know. I'm not really sure because I'm not a flavor expert. So
Yeah.
please, I'm not really sure, but that's what I kind of know.
Yeah, I think I've heard of the same thing as well. What is unique about producing natural aromas for meat through fermentation that cannot be done through other, for example, Maillard reactions or other reactions?
Well, this is a difficult question to answer. Let's say that with fermentation, you also can create very complex aroma as you can get them from the Maillard reaction or other reaction that occur on a food. So they say that the two processes in common, they can have the complexity. But when you work with fermentation, you have a lot of possibilities as well that come from the substrates and the condition. And it's also the same things that you find when, for instance, you have the Maillard reaction in the food. It really depends on which kind of reducing sugars and which kind of amino acids you have and which kind of temperature and condition you have. So it's a bit difficult to answer to this question at the moment. I think it's unique just because there are two different processes. One, it's looking at the food production, and the other one happens when you actually cook meat, and it happens at home when you use your products.
So it's more like this is one way of doing it instead of this is so much better than the other ways.
Yeah, you're just targeting a different molecule that you want to produce, and you produce it during the fermentation rather than during the cooking. But of course, also during the cooking, the fermentation products can be converted and are converted to other products.
Yeah, that makes sense. What are the biggest challenges in producing natural aromas for meat through fermentation?
Well, I mean, I think that something that can be very challenging is to get to very high levels of a certain target molecule that you're looking into without using genetic modification. So at the moment we could use CRISPR-Cas, so we can use other technique to obtain a high amount of a certain molecule in a relatively easy way, just by doing some genetic manipulation. But this is really not what we want. We want to do it in a natural way. We don't want to directly go into the genetic manipulation in the direct way. So that's the main challenge, that you have to do it in a different way, and you need to understand and do a lot of trials and try different substrates, try different conditions, try different microorganisms, do a lot of screening, and try also to understand what are the different mechanism that brings to the production of a certain metabolite.
Yeah, I can imagine. It's really complicated, especially without
maybe a bit less straightforward.
Yeah.
But that's what we want, so it's just a nice challenge for a scientist.
Yeah, and it would be very fruitful if it could be eventually achieved through a natural way, and people who are really looking for natural food can really benefit from this kind of research, I think.
Yes, indeed. Yeah, they can.
Your project is really fascinating, as super informative, what you told us about. But now would you also introduce us what kind of research is generally done in the chair group where your project is located?
I'd be super happy about it. So what they always say about the food microbiology department is that we're working with the good, the bad, and the ugly. The good are those microorganisms in fermentation that you can use to ferment the food products. So all those microorganisms, they're beneficial, and they can help you to improve the quality of a product that you're trying to produce. Then the bad are those microorganisms that make you sick.
Yeah.
So Listeria, Campylobacter, Salmonella, Bacillus cereus. So all these microorganisms that are actually pathogens and you don't want in food. And then the ugly are those microorganisms that are responsible for spoilage of certain food products. Thinking of the molds that form on your bread after you open the package, or some stinky vegetable that you left too long in the fridge. So these are like the main study. So we work with this different type of microorganism, and we're looking at genomics and physiology, pathogen ecology, and fermentation ecology, but also quantification, management, and risk assessment on the for what concerns the exposure of the exposure and the risk to certain unwanted microorganisms that can cause diseases.
What do you think is the most important quality for someone who wants to pursue in researching this field?
Well, I think that this quality, it's passion, but this stands for everything someone does in life. I think that the most important quality is to love what you do, especially when it comes to research. When you do research, it can be quite slow, frustrated, puzzling. There are many times in which things don't go as planned. Actually, very often things don't go as planned. And this can lead to a lot of insecurity and maybe feel demotivated. So you really need to love what you do, because research can be, it's for sure a fun, amazing job, but it can also be a bit frustrating and can also be hard. So you really need to love it.
I can imagine. What about the technical knowledge that is required for example, working your project?
I think for sure you need to have a background in microbiology, and background in microbiology, background in food technology, because you're working with microorganisms applied to food. I don't think there's anything really required, especially, I don't know if you're talking mostly about, for instance, students that want to apply to my project for their thesis.
For example?
Well, I think that the most important thing is that you like it, you're passionate, you're willing to learn, and that you feel motivated to work hard. These are the most important things. Technically wise, well, of course, it's better if you have knowledge in food technology and you have done some food fermentation courses and you know about fermentation and you know about microbiology. That's also important. But most of the thesis students that apply for my project are all the students that are doing either biotechnology or food technology with specialization in biotechnology. So it's really... we do always have candidates that have this technical prerequisite. So for me, that's not a problem. What I like about my job is I'm really passionate. So I prefer to have students that are really, really passionate about what they do and they're really, really motivated. And I try to also make leverage on that and try to keep my students motivated throughout all the time, because a passion and motivation are those things that are the most important. And, you know, if a student that comes and doesn't know much about microbiology might have some struggles, but if it's really motivated, can watch videos, can do some courses, can really learn. Whereas for a person that have all the let's say technical background, but has zero passion, that I don't know how to help with that. I don't know how to work with it. How can I solve that? How can make someone like the topic?
Yeah, I can tell that you're really gonna be a great person to work with if someone...
Oh, no, don't say that. No, don't say that. Don't say that. Like, you have to ask my student, and I also don't want to hear what I say. I try to be nice and I try to motivate students, but let's not infer. Do you say it like that? Let's not draw any conclusion from it.
Okay. But yeah, I understand that, of course, you want someone who share your passion to work together with, and as compared to that, maybe the technical requirements are less important. That's what you mean?
Yes, of course. I mean, not that they are less important, but there are a lot of things that you can learn.
Yeah.
But you cannot learn to be passionate about something.
Yeah, that's definitely true. So do you have personal hobbies related to the transition of protein? And does your research or your knowledge in this field influence your lifestyle in any way?
Well, I love cooking. I love cooking all the time. It's mostly in the weekends. I spend like I cook breakfast, I cook lunch, I cook dinner, Friday, Saturday, Sunday, all the time. Well, Friday not really during the day because I'm working. So the way that this relates to my passion is that and to what I do is that I really like to try new foods and I really like to try alternative proteins. Sometimes I just go to the supermarket and I try to cook them. If we look at fermentation more in a broad way, I like to pickle certain vegetables. I like to make, for instance, some fermented giardiniera. And I really like to make dough. So I really like to make bread. I love to make brioche. I love to make a certain cake. And I'm not a big fan of sourdough. Sorry, people, don't hate me. I'm not a big fan of sourdough. I really like yeasts. It's also quite lucky because I'm working with yeast in my research.
Yeah, I actually heard that if you do baking in the weekend, then you go back to the lab and then work with the microbes, then it might increase your risk of
contamination. Oh, I didn't think about it. And for me, it would also be very difficult to spot this contamination in the lab since I'm using Saccharomyces cerevisiae, cerevisiae.
So it's the same thing.
Yeah, baker's yeast.
Yeah.
Well, I guess I'll have to pay attention, but usually I wash my hands and in the lab, we work in very clean conditions. In lab, we really try to be precise and not to have any contamination. I don't touch any of my sample with my own hands, and I try to pay a lot of attention. So I don't think it's really a problem. But that's a fair point.
Yeah, I heard it when I was doing my bachelor thesis. It wasn't about microbiology, but it was more about cell culture. Then I remember my supervisor was telling me, don't do baking, don't touch yeast when you're at home.
Oh God,
you're gonna contaminate your sample. But if it's not a problem for you, then yeah.
I mean, I'm not really, I don't think it's a problem. It would also be very difficult for me to identify whether the yeast that I'm working with is the yeast, to discriminate since it's the same microorganism. But I'm pretty sure that using that the way I'm working is quite, it's quite, let's say, safe. And I don't think that I do contaminate my samples, but good to keep an eye on that.
Yeah, definitely. What is your view of alternative protein and its future development?
Well, I think that at the moment we're eating way too much meat, more than what is good for the environment, especially. So I think that we should reduce the amount of meat that we eat and also increase the quality of the meat that we're eating. So personally, I try to eat more organic meat and all get it from butcheries and places where they really do care not just for the for the life of the animal itself, but also the quality of the meat itself. So I think that we can't really keep up with the current meat consumption. And therefore, especially for those consumers like me that do like to eat meat, it's really important that the alternative proteins do provide a good, nutritious, tasty alternative to the traditional meat. So I think it's really, really important to develop good quality alternative proteins that have the same nutritional values and also similar sensory characteristic to meat itself. There are also those consumers that do not really like meat, and for those maybe they are looking for different qualities and different aspect in meat replacers, and maybe they are mainly interested in especially the nutritional value and intake of vitamin B12. But that's also something we are working on with our products. And for what I know, at the moment, the tempeh that we produce in our lab has very, very high levels of vitamin B12. And I think that those levels have nothing to envy to some real meat products.
Oh, that's great news.
Yeah. It's very, very good. You did Walkers and I did an amazing job, but also the people in WFBR, so in Wageningen Food and Based Research, Bio-based research, are really doing a great job in exploiting a certain microorganism and fermentation to get to very high levels of vitamin B12, which is really, really amazing.
Yeah, that's a big progress.
Yeah, it is.
Anything you want to tell the fellow students in Wageningen who are interested in this field, like any position for doing their thesis with you, as you already mentioned just now?
Yes. There's for sure the possibility of doing a thesis, but I'm supervising only master students because bachelor students that apply to food microbiology department are working on different projects that are also like super fun and super great. So I would say if you like my project and you are a motivated student and you want to learn something and you'd be happy to work in this field, you can for sure apply. Mainly we have food technology and biotechnology students. Usually the application starts, I'm not sure, I think in March. And then usually by June, we know how many students we supervise. I do tend to supervise up to maximum 2, maybe 3 students every semester. So if you want to send your application, write a nice motivation letter. I'm pretty sure I'd be happy to work with students. It's also very important for me to work with different master students because they really help me in my research. But I also try to give the students the possibility of using his own interest and his own point of view in developing the research. So a lot of my students come up with their own ideas on how to for instance, reach certain products of vitamin B1. And I try to let them do what they like, but always focused on the final aim of my project, which is the creation of a meat flavor based on vitamin B1.
That sounds really nice. What do you think would be a fun event idea for you for promoting the concept of alternative protein in, for example, in Wageningen University or student organization, I mean?
Well, at the moment, it's very difficult. So if I'm thinking without coronavirus restrictions, so after the pandemic, I would say that it would be nice to have an event in which people can cook different type of foods. So workshop about how to use alternative proteins, which people, for instance, can cook. Also just events in which people can have different tasting. I really love to go to food fairs. For instance, I went to Rianuga, another for instance, chocolate food fairs, and I've been to many of those. And what I really like about it is when you can try different products and there are all these new ideas and all these new startups that are presenting their own products. And I also, for instance, ate some insects. Well, because I'm an adventurous eater. I like to try new things. So I think for me, cooking workshops and tasting of different alternative proteins would be very, 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 very fun. Maybe there are also some other people that are more interested in certain kind of talks or conference or know more about the scientific background. But I think that mainly people would be attracted by, cooking, sharing food, and trying new things.
Yeah, that's a great idea. We will definitely look into that and maybe find some online alternative to that if that's possible. But
yes. Maybe if you're thinking to do that during the pandemic, you could gather some startups that produce different type of alternative proteins, and then if people sign up and pay a small fee, they could receive a box at their own place where they can taste and they can cook, and you could have a challenge of make the most beautiful picture of the food that you cook with it, or give us a review of what you think. Maybe they could answer some questionnaire. I would totally be up for it to pay some money to try different alternative proteins. And if you can send them at home, do that at home, and that would be also very nice. But I was thinking of more
like after pandemic, of course.
Yes.
It's gonna be funner, certainly. If we ever have a seminar, would you be interested in being a presenter?
Yeah. I think I can do that. Would be nice to present some of my work. I'd be super happy to do that. Yeah, I also would like to thank you for inviting me and giving me the possibility of talking about my project to a different audience than usual.
Your project, it's super interesting, and also the way you're telling it, like it's great.
Thank you a lot.
we're really happy that you accepted our invitation and agreed to be with us.
Thank
today.
you a lot. It was a pleasure for me too.
There was some very interesting sharing of you in the field of fermentation. And thank you again for being with us today. And I'm really looking forward to talk to you again sometime in the future if possible.
Yes, that would be super nice. Please keep me updated about your research and your projects, and I'd be super happy to keep in touch.
That would be great. Thank you.
Thank you.
Thank you for listening. If you have enjoyed it and would like to hear more interesting interviews about alternative protein, subscribe and follow our Facebook page of the Wageningen Alternative Protein Project. Thanks again, and we will see you in the next episode.